Here's the Aerocharger 53 series. We're going to talk a little bit about how to adjust the controller. One thing that is nice about the controllers that we build is the ability to adjust them. You can also use any sort of a boost controller, which is just a bleed off valve basically, but you can also set the controller to be the minimum amount you want and then use a boost controller to go up. So we'll show you basically how this works. This is the controller assembly here. Compressor housing, compressor cover, V-band assembly, turbine housing. This is your vane setting fitting, and it's also where the boost comes in. There's a little jam nut on here. This would be the bonnet, controller housing, compressor inlet, compressor outlet, turbine inlet, turbine outlet. So it's obviously easier to work on the desk, but you can also do most of these adjustments while it's on the application. First step to do is just to unscrew the bonnet or the controller cover. Inside of here, there's the controller cover, the boost fitting. This is a nylon washer. It's basically in between the diaphragm and the cover to keep you from wrinkling it. So that is an E-clip. It's always nice to have a couple of those extra around because they tend to fly off and get lost. This is the controller top, obviously the diaphragm, and then underneath will be the piston, the spring, the shims, and some other components. To remove the E-clip, very simple little screwdriver, really anything to get in there. That comes off. The spring is pushing then the top off. The diaphragm, the piston, the spring that was in there, which is a green spring. There is a piston shim that stays on the shaft. Inside we'll have two spring shims that will adjust the boost. They look a lot like the top, but they're not. And then this white nylon dust shield. As a minimum, we need the dust shield to be in there. That keeps the inside of the controller clean. One shim, and we have a selection of springs we can choose from. Green being the lightest spring, blue being the next heaviest spring, orange being the next heaviest from that, and black being the hardest spring there is. As a general guideline, you can count on this being 5.5 pounds with one shim. This is about 8.5, 9.5 to 10, and this starts at 15. It's always a good idea to use the spring, the heaviest spring you can, with as few shims, and not put 10 shims on top of too light of a spring. It'll keep the spring from getting bound up. So anyhow, let's put it together. We've got a couple of extra shims. It had 2 in it. Let's say there's 3. I've already got 1 in there. Let's add 2 more. Shims go in. Spring goes in. I always put the diaphragm on top of the piston. It goes over the spring. And then the top. Line up the top with the end of the rod, and I just kind of look down in the hole, get the rod on there, push it on with both fingers. Now the rod's sticking out. You can hold it. Put the E-clip basically in position. Depending on the application, sometimes it's more difficult to get to than others. That's on. Now basically the controller's back together. That is the hardest part, depending on how it's orientated in your application. On all of our stuff we try to make it very accessible. Once you get it in there though, go ahead and take your fingers and make sure that the rod moves freely. A little bit of stickiness is normal depending on how much carbon buildup you've got. but do make sure that it operates properly. You could just put it back together and you'll maintain your same vane setting, but if you'd like, pull the fitting out, make sure that you've got your diaphragm shim in there, and go ahead and screw this all the way on. Make sure it's tight so that you don't have any air leaks, but not too tight. You don't need it to get bound up. Take your jam nut that's on your vane setting, move it all the way in. Now you're going to screw the fitting in until it makes contact with the top that's sitting on top of the diaphragm, or basically the end of the control rod. So once you've done that, I call that 0. And from there, what I like to do is to go ahead and put an index mark on there. Now I know where I am. So if I wanted to open the vanes, this would be the most closed position, and this will cause the turbo to come up the fastest, but may also choke the engine. So from here, you can turn it in. That would be 1, 2 turns, 2 1/4 turns. This is basically setting how small the turbine housing starts off. Once you come up on boost, it will go ahead and open the vanes and perfectly match the engine's requirements. This is something I encourage everybody to play with a lot. It has everything to do with how fast the turbo will react, how it drives, how it recovers when you're on and off the throttle, and everybody has a personal preference. I've always joked that you may find out that 2 turns is where you like to drive it, and then if you ever hurt your motor, if you've got your father-in-law or brother-in-law that has to get on your vehicle, you can actually screw the vanes all the way in, and that will slow the turbo down as much as possible. To see exactly what we're doing there, here's a back wall. This is actually out of a 66 series turbo. As you can tell, it's much larger. But here's the rod that we're adjusting. And basically the end of this fitting is hitting on the end of here, and this would be the 0 position, and this would be the full open position. And typically you want to go into where the engine is just happy enough that the engine will come up and run on its own, but it brings the turbo with it very quickly. If you had the vanes too open, it'll act more like a conventional turbo and be slow to spool. If you have it in the sweet spot, say something relative to that depending on the application, what happens is as you come up on boost and your engine continues to rise in RPM, the CFM that's flowing through the engine needs more space. So these vanes will constantly move to perfectly match the requirements of the engine. So I do encourage everybody to spend a lot of time playing with their boost controller. Whoever builds the kit, if it's us, we certainly have a recommendation that we like to start with. If you go up in altitude significantly, you may want to change it because the power that your engine's putting out prior to boost changes. And just driving conditions. If you're on a road course, you may want to open them up more if it's rainy that day and you don't want the turbo kicking in. Or if you're in something like a hill climb situation, you want them very tight so that it reacts very fast. We make the shims and the E-clips and the springs available to anybody. Give us a call, we'll get them out to you. If you need help setting them up, by all means give us a call.